Hello, welcome to our demo of our Deterministic Hypervisor. Let me just start the test and then I'll explain what's going on. So right now we're testing randomness. We have some code here, let's check it out, which fetches random a couple of different ways, hashes it, and then prints that out. And hopefully what we see if our hypervisor is deterministic is that these hashes all match identically every time we run it. So let's try and build it locally and test it here. Run it a couple times and we see the hashes differ from time to time, right? And that makes sense. That's how randomness is supposed to work. But I've also just ran the exact same code in our hypervisor, and it's on run 2 out of 3. And let's see how it performs. So we just finished the second run on its third run. Shouldn't take more than 15 seconds or so in total. Okay, and it looks like all the runs have finished, and our testing framework does show that all of the registers and memory and devices match between all of the runs in the hypervisor in the virtual machines, but we can check it out ourselves. So the ID is this. Let's check the first run, and these are the hashes and the IDs. Okay, let's try and compare to the second one, just the last 20 lines or so. And we see from the first run to the second run, the hashes all do match exactly in 9C, 9C. All of these match exactly, so we know that our randomness is deterministic in our hypervisor. The second example I'd like to show is our race conditions. So let me just switch to this built race file that I have and run another test. So our race conditions work by just spawning two threads to try to write to the same file. One tries to write the letter A, and the second one tries to write the letter B 50 times. So let's just build it locally and run it. So this will spawn two threads to try to write to the same file, racefile.out 50 times each. And let's try and read it. And we see that, yeah, that's what they've done. And they do go back and forth pretty much exactly. We see here at the very start B got in twice again here. So it does go back and forth. This is dependent on like the internal scheduler. But if we, so it matched at 0, 1, and 2, 3 for B. Right? If we remove it, try to run it again, and try to read the new one, we see obviously this doesn't happen again because the internal state of my computer has changed. But what we'd like to see is that if we run it in our deterministic hypervisor, the race conditions match exactly at the same time or the same way every time. And as we see, it ran three times, and yeah, sure enough, the registers and memory match, or the final registers and memory matches in our hypervisor. So that's super cool. If you want to see more about how it's made, you can check our source code at /pgrok/dhyve source, which is where the source code lies. All right, thank you for watching.